All right, recording is on. Welcome to the Network Plumbing Working Group meeting for October 11th, 2018. And first item on the agenda is from Tomo and Corral is default network in multiple network scenarios, changing the default network per pod. So Tomo and Corral, you're up.
So this particular issue is based upon number of requests we got from the user because there was issue they were reporting that they couldn't able to change the interface type. For example, if they're using funnel, they want to change it to MAC VLAN for some pods and certain pods to VT interface. And the reason they said that they want to change the interface in order to consume the services in certain interfaces, because there is the limitation that you can't expose the service other than ETH0. And I don't know whether it's a legitimate use case, because I never came across such a use case to change the default network, because currently default network.
I'm sorry, wait, can you go back and explain the problem a little more slowly? I'm not sure I follow.
So for example, if you take a funnel, right? So funnel always use the with pair, okay? So the default interface, this ETH0 will be a with pair. So you will consume certain services using that interface. And they have another use case in which they want to consume certain services in funnel, but with IPVLAN or MAC VLAN or kind of a different interface.
But isn't that Flannel's problem?
No, it's not Flannel's problem. So they want to change.
It sounds like they're asking for something that they're asking Flannel to do something that Flannel doesn't do. So
No, Flannel do it. Flannel do it actually. The Flannel within Flannel we have delegates, so we can change the type of network attachment of Flannel actually.
So let me make this short. And the actual issue is actually this is slightly not the out of scope of the network pumping working group version 1 draft. This is just the maltus.conf, or just the CNI config file of multiple network we're giving. So let me try to share my screen first. Okay, let me try to share. Can you see my desktop?
I can see it, yes.
So the previously we have the delegates. Previously the Maltus uses the delegates the field in JSON file. So this JSON file is for just SC, CNI, netd, maybe 10 Maltus or something. This stuff, and then we create the delegates field, and then create the how do I say, child JSON file is put it like type runl, and then let's snip it, and then the next is we botham. That's the background.
I think another way to describe this, Mike, would be that we've had requests upstream in CNI to change the way that a particular CNI network attaches a pod based on whether it's a VM or a container. We're still trying to figure out in the CNI maintainers group how that should actually happen. But the argument, I think, here is that it's the same logical network that you can think of that things are being attached to. It's just that that attachment mechanism might vary based on what kind of pod it is, or maybe even what node it is. I'm not sure if that.
Well, I understand variation depending whether it's a pod or a container, because they typically want slightly different plumbing.
Right.
So that would make sense to me as like an additional parameter on the CNI request saying which style of attachment you want.
Yeah, and that was kind of what was proposed upstream for some of the CNI plugins. We talked about that as the maintainers group and thought that was a little bit too specific and that there were other use cases for some of that functionality. So we're trying to come up with a more generic way of allowing this to happen. But I mean, just using that as an example, I think is kind of a more specific use case of what Tomo and Corral are trying to talk about here. That, you know, we're still talking about perhaps the cluster-wide default network. It's just that right now, the way that you attach to it is through, you know, one single network, and that might not be flexible enough for all different types of pods.
Okay, so I see. So the problem is we want to allow different ways of attaching to the default network.
Yeah, potentially on
Right.
a per pod basis or per.
Right.
What might be a pod, but might be a container, but might be a, you know, who knows? Yeah.
Right.
I think you've got that correct.
Right. Okay, I see.
Yep. So the currently Maltas use the delegates config, but in this proposal we are likely to add the cluster network and a default network configuration instead of the delegates. So now I'm thinking about the once we introducing this stuff, the delegates keeping to their models, but this is kind of the transitional phase or something. So in the
okay, I'm sorry. Can you back up again? I'm sorry. In this Multus config, so I understand Multus as an implementation of this multi-network thing, and its job is to read a pod's annotations and call out to the appropriate network attachment methods. So what's delegates doing in the Multus config?
The Multus config is provides the let me correct the first the syntax first. So I need to double. Okay, go ahead, Carl.
Mike, the delegates are kind of like the network which is available in the node. For example, Funnel, or it could be Calico, or it could be Weave, or it could be any network, the overlay network which is available for that node, so that all the pods can talk to each other.
So is this another way? Are you talking about the default network?
Yeah, default network. So delegates is actually the current implementation is that we having an array of network, and the first delegates array will be the default network. So in this case, the funnel will be the default network for that pod actually.
So
yeah.
What else is in the delegates array besides the default network?
Besides the default network, you can expand this array to next to MacVLAN, next to you can use it for SRIV, or you can extend this particular delegates array as like you want.
So the delegates field plugin is used as the default plugin. So if the if pod is launched without any network annotation, the both, so currently the Funnel and the MacVLAN, for example, it will be added. Two interface is added. And the first item, the Funnel, is also recognized as the Ether0 interface, kinds of the default cluster network stuff. So which the Kubernetes uses this network is for pod IP, and then the other liveness proofs or something like that. So that's their current implementation.
So what would you guys suggest to, you know, as a proposal to allow this functionality in the CRD spec? Would it be something like additional annotations to say that this pod should have a different default network than the default network?
Oh, sorry.
Or would it be, you know, something not necessarily annotation based?
Oh, sorry, I'm a bit confused about that. So let me move to the maybe the issue stuff. So
So
currently,
I'm getting the opinion here that this discussion would be a lot clearer if we remembered.
go.
I think this discussion would be clearer if we remembered that the CRD we defined is not network. It's network attachment definition.
Yeah.
Right? And so we're actually debating exactly this point. We're talking about multiple ways of attaching to one network. So keeping in mind the distinction between a network and an attachment method is going to be important in talking about this problem.
Right. I'm just trying to think, like, how can we bring this up one level and, kind of brainstorm how it might fit into the CRD spec. And then, if we can get a proposal for that, then we can kind of bring it to the wider group and see if it works for other use cases too, and see what everybody thinks about it. I mean, I think at least at this point, and anybody else who's on, correct me if I'm wrong, but it seems like most people understand the problem here and what the use case might be. But there's just kind of a question as to how could this be addressed through the spec, and should it be addressed through the spec?
So it looks like what's on the screen now is a plausible proposal. It looks like what they're saying is we'll define a new annotation that identifies the method to use to attach to the default network.
Yeah. And I think one thing that if we do put any of this into the spec that we need to be careful about is to put some parameters around the networks that actually get attached, because Kubernetes requires certain things of all pods, at least at this point, like 2 pods on the same cluster. Basically all pods should be able to talk with each other because they're all hooked up to the cluster-wide default network. I mean, that not exactly, because there are some tenancy issues and all that, but there are some guarantees that Kubernetes asks of the plugins, including around services.
Right. I thought you already satisfied that by saying that this is all about how to attach to the one default network.
Yes.
They should have
I think we should make that clear.
It's all same network actually.
Yes.
They should have L3 reachability, right? They don't say anything about L2, or?
No, I don't think we should say anything about L2 or anything.
I mean, Kubernetes has such. It just says L3 reachability, and then you have all the policies that direct whether they actually are able to talk to each other.
Right.
So, Dan, I also concerned that the some cases the kubelet or API server may have the binding some certain IP address. So, like the if the default network used by the funnel at that time, maybe the 10.1.1.1 is already only this IP address is binded. At that time, even though we adding the some Macmillan network, which is not binded to the 10.1.1.1. At that time, even though the network default is override, the kubelet does not communicate to the Macmillan in certain case. So
yeah, and I mean, I think if we do something like this annotation, we are allowing cluster administrators to shoot themselves in the foot and to violate.
It's not just administrators, right? It's anybody who could find a pod.
Yep, exactly. So basically, we are allowing that to happen where it currently is not allowed to happen. Which is why we should, if we do this, make it very clear that you should make sure it's the same logical network. And that's kind of where we leave it. But if you
could we go farther?
Pieces.
Could we add? Right now, we get into the CRD rather than the annotations. Could we put something in our CRD, a bit that says whether or not it attaches to the default network?
That's interesting. Is that kind of like a flag in the CRD that says we consider this part of the default network?
Exactly. Right. Then we can check.
True. That's a good idea.
Yeah.
We should explore that.
So Mike, at that time, is there any verification phase you are thinking about that? I mean that admission controller or some certain mechanisms can check whether this network is available to connect to Kube API or
Exactly, right? That could be done either in admission control or in the the implementation of the multi-net, or well, of whatever interprets this, right? It doesn't even have to be the multi-network thing now, right? So now we're getting into an interesting thing here. We have this definition of network attachment definitions, and they can be used either to make additional attachments or as alternate ways of making the primary attachment. And so maybe this becomes something that the kubelet itself, actually, right, it is the, let me think about this. Yes, it's the kubelet. Kubelet actually needs to look at this annotation. This is actually a change that's relevant to the kubelet. So the verification could be done either by the kubelet or in admission control or in the strategy, right? The strategy has a validation. So the pod strategy could check this also. Although the problem there is that's checked at one point in time. It might be more appropriate to check it at the kubelet time. Well, they shouldn't be very different.
I see. I agree on that.
Yeah, the admission controller could be the nice part to put this one. Yeah. Yeah. Cool.
So does it look like we've got at least some idea of where to go with this, and that maybe Corral and Tomo, you guys could develop a more concrete proposal for the spec and then send it to the list or bring it up in a further, like next week, or not next week's call, but call 2 weeks or something like that. Does that sound reasonable?
Yeah.
Yep.
Okay.
Yep.
Cool. Thanks, guys. Any other comments on default network stuff? If not, is Suresh able to join? Yes, I see Suresh. All right, Suresh, you are up on consistent interface naming.
Yeah, so I just put in text into the version 2 document. I don't know if people got a chance to look at it. Hello?
Yeah, I think people are going to look at it.
Okay, I thought like everything went silent. It's like, okay, what did I write there, Can you throw it up in there, Dan? Like, can you share it, like, so people can look at it?
Yeah, I will do that. Hang on just a second. All right, are you able to see my screen?
Yeah.
Except for the Zoom group chat. All right.
So the background is, right, so like, Per and I have talked about this earlier, like, what we have done is we're trying to do some kind of dynamic networking support into Kubernetes. So we'll be able to add and remove like new interfaces and attachment points into something that's already running. And so what we want to do is like, come up with a name, a consistent name for like a device. So like we would know like, what kind of name the device is going to get. So pretty much like what we do is we take the network name as a key and we run it through like some kind of hash function and then truncate it so that like given a network name, what is the name of the device that's going to be created to get attached to. So like we truncate it to like 12 characters. So we'll have a 15 character device name. So we know it up front and we know what to look for. Does that make sense?
Well, I'm not sure it's the problem again. Since we already have a way to make it predictable by having the client specify it, why isn't that good enough?
So as I said, right, like, we are trying to do something. We have an agent which is sitting down and observing if somebody is adding annotations into the system and try to do the hookups afterwards, right? So that's kind of the prerequisite why we wanted this. And so if you don't have a need for like dynamically adding things in there, I don't think it's like relevant straight away. right? So if the client specifies it, like you need to make sure that like that thing is unique somewhere. So like if it says like net 15 or something like that, or ETH 15, then you need to make sure that is like unique somewhere. So it could fail at runtime. So this one, like we know exactly what's going to happen before.
Well, I mean, you're replacing one code with another, right? You could have a hash collision, or the client could mess up. I think it's easier to get 100% out of the client.
Okay. So what is the proposal, Mike? Like just so I understand. So you wanted the name to be specified by the client itself?
The thing the thing's asking for attachments, right? It could just take responsibility for giving them each unique names.
Is that possible for the client to generate the pod spec? Then you can generate the unique name in the
Maybe we're not. I'm sorry. We're apparently we don't understand what we mean. Each other means by the client. What I meant was the thing that generates the pod spec.
Yeah.
Okay.
Yeah.
That thing could generate unique names for each attachment.
I was saying the same actually. Yeah.
Okay, makes sense. Okay, that makes more sense, Mike. Okay, let me think about it a little bit, and then Per, did you have anything to say there, or like should I go back and think about it whether that would work?
So basically, like Suresh says, we generate a name, and sort of we own the context where the identities are generated in, right? So our function, we will find if we have a collision, and then sort of generate a different name. It's like you say, the importance is uniqueness. And once you have the name, you sort of use that name. But we have a much longer name for our interfaces internal in our system. And then we need to generate, call it the interface name, and that's what we do with this net 12 and a hash of 12. And if we have a collision, we actually regenerate one more.
So one thing that occurs to me is that I don't think that this proposed solution would work for multiple attachments to the same network, because both of those would use the same network name. I mean, there are different ways you could solve that.
Yeah, like like this, like we were thinking of like a collision counter, like where if you have a collision, like you increment a number and run it again. So that's kind of like how we get out of the collisions.
I guess I'm still lost to the problem. I understand that the names need to be unique, but that's not exactly what you're talking about. Some part of some system needs to be able to predict a name that's created by some other part. And this is the part that's getting confusing. What is the first part that needs to know the name that is going to be created?
So that's the part like I was talking about first, Mike, right? Like we have like something called a pod agent that's like listening to changes in the annotations, right? And that's pretty much the part. So we are doing something dynamic, and that's something I want to demonstrate, like so that we get people in the context. That is something we plan to do at the next meeting. So maybe this we can table this until we can get into the context, and then we talk about like why we do this. Does that make sense?
Well, I understand the idea of a pod agent. My team wrote one a couple of years ago. The way we dealt with it, if I recall correctly, was again leveraging the fact that these things have names. Yes, in our context, they all had unique names coming in, so there was no question or no problem.
The network had a name, you say?
Yes. The network attachments. In this case,
we don't have a network attachments until we create the interface here.
Well, I guess my point is that in our context, the incoming thing had a name for each attachment, so there's not a difficulty. So, but the point is that, though, what I'm saying is that in our annotations, I think maybe I'm starting to understand the problem. Right? In our annotation syntax, we do have the option to name each attachment. But I guess your problem is you want to write a pod agent that works in both cases, the cases where the annotations are named and the cases where it's not named.
Yep.
Right.
And specifically where they are not named, but yeah, exactly.
Of course. All right. And why isn't it enough for this pod agent to simply, this pod agent is going to be the one that's invoking the CNI plugin, right?
Yeah,
Yep.
yes.
So it's going to know what interface name got chosen, even if it couldn't predict it, right?
Do you know which interface names that are already used in the other namespace that you're going to place them? I guess you could always check.
No. So I'm saying something simpler. This pod agent, when it
Mike,
makes
you want to check the return, right? Like, what got returned after it got created. Okay.
Right. Look at the return value. Why isn't that good enough?
Yeah, good point, Mike. I'll just run this through, right, and see, like, if you get stuck somewhere and then get back. So maybe that is an easier solution. So okay, I cannot immediately think why not, but just give me some time. I'll just think over it with Per and then get back to you. Okay.
Sure.
Yeah.
Okay, that sounds good. Thanks, Suresh.
But like Suresh said, next time we will plan the demo. So basically, what the inside of I guess you can say, Kubernetes-based router looks like, and where we can handle as many networks as we would want in a network solution. Where we're running it up to 16,000 per switch so far, different networks. And it looks fairly fun when you look at it from inside Kubernetes.
How much you said actually?
16,000.
Wow. Looking forward to see the demo.
Yeah, we actually had a real customer asking us for it, so that's why we went ahead and did this, to scale beyond 4,000 VLANs. That was a specific requirement from them.
Okay.
And so they came up with 20,000, and they said oh, let's do 16,000 now.
Wow, cool.
Yeah, and Linux handles it surprisingly well. So it's fun. If you do ifconfig, it takes forever to see all the networks in there. If you do IP space L, it's just as bang, and you have all the interfaces listed.
All right.
Okay, sounds good, guys. I'll get back on this to Mike, so we can probably take this over email. I'll have a chat with Per and Abdullah as well, and then we'll try to summarize, if that's a direction that would work.
Okay, thanks.
Okay, thanks, guys. Talk to you soon.
All right. Next up, Corral multi-network impact on Kube services.
Yeah, so let me share my screen. Actually, I forgot where is the button to share. Really? Yeah, I got it. Oh my God. Can you see my screen?
Coming, yeah.
Yep.
Okay, cool. So last time I was boring you guys with a lot of text. So this time what I did is I just put a example how it looks like in overall. So for the proposal assumption, let's see that we have two networks in the cluster. Both is network A and network B, and network A is like overlay network. For example, it could be Funnel or Calico, and this is the network which will be attached to the ETH0 interface inside a pod. And network B is a kind of private network, so not a private network. It's also a cluster-wide network, but it's maintained by the cloud admin. It's the own network. It's not Funnel or Calico. It could be any network, using private networks. So both network A and network B are spread across the cluster. So it means that they can communicate with each other.
Well,
so,
to clarify, do you mean that the two networks can communicate with each other, or simply that because all pods are attached to both networks, all pods can talk to each other.
No, they are actually you can kind of both network A and network B are attached. Means you can connect, both things are connected to your virtual router or something
Got
like
it.
that.
Okay.
Yeah. So in this scenario, so what I'm trying to propose is that, okay, you have the network attachment definition. So I'm trying to introduce a field called cluster IP address. And this is a cluster IP address is similar to a service. Maybe the name may be misleading. So it could be a service CRD range, which you'll give it to the API server. And so this part is clear, right? Why I'm introducing this service CRD. So why am I?
Yeah, I think something that would make it a little bit clearer would be not to call it cluster IP, but you could do like service IP CIDR or service CIDR or something like that.
Service. Okay. Yeah.
Yeah, just do like service CIDR.
Yeah.
That probably would be clearer.
Okay. Cool.
Now
So
you're skipping past discussion. I just started reviewing this a little bit before the meeting, and you're skipping past the really basic point here, which is, are you or are you not assuming that we have virtual IPs that work on these with these additional networks, right? I thought I saw something saying, hey, we're not doing that. We're just going to use endpoints and headless services.
yeah, we're using this. I will explain you both the things actually. I will go ahead. If you see in the example, I will explain you that one. Yeah. So this one I introduced from I think in the last meeting I didn't introduce, but I have a very broad brainstorming session internally and also with other stakeholders. And then I will explain you why I'm introducing this issue at the end of the document actually. And next one is that we create a service, and which is without a selector actually. Basically you creating a selectorless service, but using the service with the network annotation. So in this case you basically using the same network name which I explained to you before. So in the first case I'm using the something called bridge config. This is the name of this network attachment. So I'm saying this service will be exposed in this particular network. So that's why I'm exposing this network attachment name in the service. And then when I try to create this service, it will invoke my multi-network service controller, and it will get the IP address from this particular range. It maintains this range because it's created here. It maintains this range and give you a cluster IP address. So you can create a service with a cluster IP address in Kubernetes. So it will create a service with this cluster IP address for you. So it means that this particular service will be exposed in this particular virtual IP address. So in this case, it doesn't have any endpoints because you are not creating any ports in this case. So it doesn't have any endpoints in this case. Then you go back and then create a deployment, the same example, the host name deployment. In this case, you mentioning the network annotation, and in this case, you're saying it's bridge config 1. So when it created, you have any CNI or any implementation which is based upon the multi-network spec version 1. For an example, in this case, I took Multis. It could be any CNI, or it could be any implementation which is based upon this one. So what it can do, that it can get this information of routing from the network attachment definition, and then it can inject this information in the routing table to this particular interface. For in this case, the bridge config 1 will be net 0. So it will say is for this particular virtual IP address range, you have to redirect the traffic to net 0. So this particular routing information will be injected in the pod network namespace. And after that, after this creation of this one, my multi-network service controller will be observing this pod spec, and once this network status has been populated, it will get the IP address of this network bridge config 1, and then it will populate or create the endpoints for you. So in this case, it will create the endpoints with this address sub IPs. So in this case, I created like two pods, two replicas. So basically, it will get two IP addresses from two pods, and it will create the endpoints for you. And by doing this, it's very simple that you don't need to change anything on the load balancing or in kubeproxy. You don't need to modify anything, because once you create the endpoints, automatically the kubeproxy will be invoked, and it will automatically take the service virtual IP address, and it will populate the endpoints for that with load balancing mechanism on IP tables.
Okay, I think we need to back up and discuss. I'm sorry, some important preliminaries.
Sure, yeah.
Let's just talk about routing. Just plain routing without any services. Let's just talk about we've got this multi-network attachment business. Forget services. Suppose I've got a pod with multiple attachments. It seems to me that if two pods are going to communicate directly, no VIPs, just directly with their extended addresses, there already has to be routing getting set up correctly.
Yeah.
So if I've got a pod that attaches to bridgeconf1, or attaches, more precisely, attaches to some network using the attachment definition called bridgeconf1, that bridgeconf1 attachment method has to actually set up the proper routing so that when my pod sends to any of the addresses on that network, it actually runs through the network interface that the bridgeconf1 attachment made.
Yeah, so in this case, what happening is that in all the case, it will be routing by ETH0, right? By default, gateway will be ETH0 inside the pod. So it will be always routed to ETH0. So as I said in I
think that's wrong.
Same here.
Yeah, that's wrong. That's why we are
even without services. Forget services. It's wrong. Period. From the get-go, out of the gate, it's wrong.
In this case, if you want to reach both the networks, right? So
exactly, you can't reach another pod directly unless the routing is set up correctly. You can't.
And the only network that you can assume that is for is on ETH0, right? On the cluster network. There you have whatever we do, we have to guarantee that. On the other interfaces, it's not guaranteed.
Right. The whole point of these additional sidecar networks is that they're not reachable. They're not necessarily reachable from the
exactly. That could be a route pointing into a VPN to a home office.
Right. They could, right. So they may or may not be reachable. So the point is that even regardless of services, the baseline proposal, and if we didn't write this, it was a mistake. We in our baseline proposal, we must say that the network attachment definition, the CNI plugin that gets run, needs to set up the routing so that IP packets addressed to an address in the sidecar network get routed through the sidecar network interface.
Yeah, I completely agree on that one. So,
are you even sure that the CNI can do that? Because the container itself can always override it, right?
Yeah, so you can do it actually. So there are certain mechanisms which we are obtaining that one. So in our case, what happens is like all the pods in our case will have a management plane and control data plane. So in this case, we are completely isolating the network actually. So the network A and network B can't talk to each other. So that's how we're not facing this issue, because each pod will have the two networks and it's fine, it's working fine. And we got a customer use case. In that they said, "You look, guys, so this won't able to run because we can't able to expose the services in net 0 or net 1 interface. Because of that, we have to maintain a large IPAM information so that it able to all the pods could able to communicate with each other." So
I don't understand the statement.
yeah,
If the routing table is getting set up so that the network A addresses are reached through the network A network interface, then it does work.
yeah, it does work, but the thing is that you have to maintain, or someone has to inject this information, right? So that's
The CNI plugin that creates that network interface has to inject a route.
yeah. So
For directly attached addresses, that's fairly simple. But if you're gonna reach other networks beyond, right? There's no way that the CNI can do it.
yeah,
I see.
Unless we add all that information in.
Okay, so your point is the problem concerns not the subnet. That's obvious, but the other subnets that are reachable through there.
Yeah.
yeah.
And the only way I think that can be solved is by using, in reality, VRFs inside the container.
Whoa, wait a minute. Whoa, I think you jump into way more complexity.
I know. But that's what anyone that runs, what I'm saying is this, that anyone that does route injection into a container has to be extremely careful.
Yeah.
That's pretty much what I'm saying. And in the generic example, you will have to use VRFs because you need to have a different routing table for ETH0 than you do for the rest of the domain, because you can have a default route that points not to ETH0.
I don't even know what it means to have multiple VRFs in one network namespace.
It means that you have different routing tables, and depending on which interface something goes out on,
Well, slow down. Wait a minute. If I'm writing a client, it talks IP. It doesn't even talk to a network interface.
So basically what it means is that anyone that writes such an application needs to be completely aware of what it's doing. You can't shoot in the VRFs underneath a normal application. You have to code towards that, you know that you are in the VRF.
Yeah, this is a big leak in complexity. I'm not sure we want to go there. Yeah. So
I think we're going to end up there, but that's still less complex than what I was scared of for a while ago.
Well, can we try something simpler? Can we say, and maybe we don't even have to introduce something. I don't know. Is there a standard CNI plugin that adds routes?
There isn't at the moment. Peter White, if you remember from last time's demo, they did contribute their source-based routing plugin at this point.
That was really weird, the whole way they had it working.
So
yeah, I wouldn't talk about source routing. I would just say, just like we have, I thought we had, CNI talks about, plugins that do stuff like adjust QoS, right? Couldn't we have a plugin that adds routes?
Yes, you could.
Yeah.
Right? And then a network attachment definition can say, hey, by the way, through me, you get not only to my subnet, but these other 3 subnets.
Yeah.
Yep.
Normal CNA also you can do it, right, Dan? So in the normal CNA you can
the IPAM has a route section.
Yeah.
So you can add
so you can do it right now, actually.
It's true.
Yep.
I mean, that doesn't require that you use the host local.
Yeah, that's a.
Sorry, not host local, but that you specifically have set up in the plugin for adding those routes, which not all of them do.
Yeah. So you have to know this information beforehand, actually. So to do it for you have to maintain this information for each network attachment. It's not an issue if you have 2 or 3 attachment, but if you are going for a very cluster-wide application or implementation, go ahead.
I would say that if it's the person that defines all these networks is, call it the cloud provider, the infrastructure owner that knows all the routing, this can work. If you're starting to do sort of a VPN service or something like that, where the routes will be injected by not the infrastructure provider, but by the tenant, so to speak, it will not work to do like this.
Yeah.
That's my take on it.
Yeah, yeah, you're right. Yeah. So,
So it's a
the
step. It's a step on the way. I'm all for it. It's just that it doesn't. So I think sort of have this, and then you have the last one, this big sledgehammer. That's the VRF sort of way of doing it, but that sort of is really advanced use, and have something on the way that makes it possible for many use cases to for work. I'm all for it.
This really calls to mind the network service mesh ideas as well.
Yeah.
so in network service
Mike,
mesh,
Mike,
they have.
Mike, you will be at KubeCon, right?
Yeah.
Actually, I haven't started arranging my travel yet. I hope to.
Okay, because then I think for some of the stuff I would love just to have a whiteboard and draw things.
Yes.
So in this case, what is happening is that the back to the question about why introducing the cluster IP address. So this is an open question. I put it. So the mechanism how to you can route. So if I want to consume this service right inside a pod, then I have to make sure that the particular thing, the request will go to net1 interface instead of ETH0. That's why the introduction of cluster IP address, service CRD helped me, because when the DNS lookup comes up, I will get the cluster, service IP address. Then
Okay.
within this, yeah,
I'm sorry, but can we back up on that? Because
yeah,
as I said earlier in the document, there's something saying no, we're not going to use any virtual IP addresses.
yeah, I written that one, but later I try to implement it, and later I figure it out that is causing some trouble. Then I changed that idea actually.
So yeah, there's trouble both ways.
Hmm.
But so it seems to me the trouble, if we're going to say that there are virtual IP addresses, you're immediately faced with the problem of kube proxy does its job by putting stuff in the main, in the host's main network namespace, which might not necessarily handle the packets involved.
Can you explain me a little bit more on that actually?
Sure. Or Dan sounds like he's about to say something.
Yeah, I was going to say, I mean, kube proxy depends on being able to somehow directly send a packet for an endpoint to that endpoint.
Mm-hmm.
So essentially what that means is the host needs some like management port or something else access to each of the networks.
I would say it.
So
I mean, that sounds very abstract. A little more concretely.
yeah, it
A little
does.
more concretely, the way I understand it, right?
Mm-hmm.
Actually, I haven't looked at the IPVS thing, but the IP tables mode and the user space mode of kube proxy, the way they work, a critical part of what they do is both of them. They inject IP tables rules in the main network namespace
In
of
the
the
host.
host. Okay.
Yeah.
If you've got a CNI plugin that does its work by, creating a network interface in the network namespace of the pod or whatever network namespace you're dealing with, which in general is not the host, right? It's some other network namespace. You've
Mm-hmm.
got a network interface in there, and if the packet goes, kind of directly into some kind of encapsulation or something, then the host's network namespace never sees the packet, doesn't handle do the IP handling of the packet. So all the stuff the kube proxy put in there doesn't have any effect on it.
Absolutely.
I mean, the way that some network plugins have done this is that all service traffic goes, at least in the overlay case, all the service traffic goes out of the overlay to the host through this kind of like management port, then hits kube proxy, gets sent over the node's network connection to the other node where that endpoint that kube proxy has selected lives, and then goes back through some kind of like management interface into the overlay. I mean, that's obviously one way to do it.
But
That
I don't
uses
understand
kube
it.
proxy.
Yeah, I don't understand it.
But another way to do it would be to replace kube proxy by whatever network plugin you have and handle all the service traffic internally between the pods.
Right. Someone an operator who is deploying such a CNI plugin could also deploy an alternate or additional solution. I didn't understand what you said about the first one because, I'm sorry. Let me go back and review most basic question here. Are we supporting overlapping IP addresses here?
Overlapping IP address.
Yes, can two
In the
different
same
networks.
in the same container?
No, not in the same
No,
container.
not in the same.
On can two different networks use the same IP address for completely different purposes?
As long as they don't connect, as long as those two interfaces are not connected to the same container, probably.
But
Yeah.
but as soon as you run that traffic with those IP addresses through the host's main network namespace, you now have an ambiguity. You don't know which network they're bound for.
Mm-hmm.
Yeah, if we're using kubeproxy, that is correct.
Absolutely, yeah.
So in the case of overlapping IPs, which is what my team faced a year or two ago, we immediately ruled out or discovered, figured out that we cannot use kubeproxy because the IP addresses are ambiguous if you just look at the IP addresses.
Well, here's it. I mean, you can't use kubeproxy as is. You could,
right?
Which I guess is the goal of all the stuff we're trying to do here is not modify Kubernetes, but
right.
Yeah, I mean, you can imagine a kubeproxy that was multi-network aware and then just directed the traffic to a particular endpoint through a given interface. Obviously, that doesn't help us much.
Yeah.
So yeah, it could work, but.
So in this case, I'm considering the networks are like overlay networks, like Dan said, that the one you're saying is like kind of IPv LAN or MAC-VLAN CNI plugins that will do some kind of encapsulation or something. That's what you're trying to say? Whether I couldn't able to understand.
So what I'm saying is, those of us who do support overlapping IPs, we have to encapsulate those IP packets because by themselves they're ambiguous. So we encapsulate it with Geneve or IP and IP or VXLAN or VLAN or something to disambiguate it.
Okay, I will consider that one. This one.
All right. Given that we've got only a couple minutes here, what are the next steps on this one? Are you going to take a little bit more time to think about the issues brought up here, Corral, and then modify the proposal?
Okay. Yeah, I will try to modify the proposal. My use case was just the overlay networking, like a Funnel or Weave or Calico, basically use with interface actually. So maybe I try to put more brainstorming on the IP address overloading and IP address encapsulation to be addressed. Yeah.
Okay. In our last 2 minutes, does anybody else have anything that they'd like to talk about?
No.
So next week, our team is also planning for a demo. So I think by next week there will be 2 demos. So we are planning to showcase device plugin and CNI alignment, how this mechanism should work like. With also we are trying to show that particular POC with SRV network device plugin with NUMA awareness. So if you guys interested on this topic, please come to the next meeting to see our demo.
So next network plumbing working group or next SIG network?
No, it's an plumbing working group actually.
Okay.
It's
October 25th. Yeah,
okay.
And it looks like we've got both 2 demos, Suresh and Per, and then the Intel one. So I guess everybody gets maybe plan on 20 minutes tops because we probably have a couple other things to discuss. And if it turns out we don't have additional agenda, then maybe we can do like 25 minutes or something like that, including questions. So.
Okay, cool. Yeah.
Hopefully that sounds good.
Yep.
So. Yep. All right. Thanks everybody. See you in 2 weeks.
Have a nice weekend, guys.
Yep.
Thank you.
Yep.
Bye.
Thank you.
Bye.
Guys. Bye. Thanks.